guys, this is Professor Janacek. I want to go over one-sided limits and limits of polynomial irrational functions. Let's start with the right-sided limit. The right-sided limit, we write that as the limit as x approaches a, but to indicate that it's from the right, we'll put a little superscript of a positive, little plus sign above that a, of f of x is equal to L. Now this is defined the same as the limit definition, except that our x values are all going to be chosen greater than a. A left-sided limit, very similar. The notation is the limit as x approaches a, and then we put a little superscript of a minus sign on that a to indicate that it's a left-sided limit. But then the rest of the limit notation is the same. And this definition is the same as the limit definition, except that our x values are now less than our a value. So we're looking at just limits from the left or limits from the right as we approach those x values. Let's take a look at an example of this. Here we have a function g of x that looks something like that. Let's determine first what is g of 2. G of 2. Well, here is the x value 2, the g value that it matches with that. That's 2. That is 1. So it looks like g of 2 is simply 1. But what about the limit? Let's take a look at the limit as we approach 2 from the left. So just from the left-hand side, approaching g on the left-hand side, it looks like it's really going to 4. So that limit is 4. How about as x approaches 2 from the right? What is the limit of g of x? Well, from the right, here it is. It looks like it's going to 1. So, what does that mean for the limit as x approaches 2 of g of x? Notice this is just as x approaches 2, not from the left, not from the right, just the general overall limit. Well, it turns out, because the limit from the left is different from the limit from the right, that this does not exist. So, these two limits must be the same in order for the limit to exist. How about limits of polynomial and rational functions? Oh, you're going to love this one. Check this out. The limit as x approaches a of a polynomial or a rational function is simply f of a. This, of course, is for the denominator not equal to 0. On those rational functions, make sure that denominator is not 0 and we're good to go. So let's take a look at an example or two of this quite simply. We have the limit as x approaches 2 of 2x to the 4th minus 8x minus 2. Since this is a polynomial, all I have to do is evaluate that polynomial at the a value. Do that computation, and let's see, we end up with, looks like 0. Pretty simple. This next example here, we have the limit as x approaches -1 of x minus 1 over x. This one is rational. And we can use the same trick. Use that a value, our a in this case is -1, put that in place of x. As long as that denominator is not 0, which it's not, we are good to go. And then simplify this rational expression, and we end up with +2. All very simple. I want to take a look at one more example. In this case, it's not a polynomial, it's not a one-sided limit, but I just wanted to remind you, what if you have to find the limit of something like the cosine of 1 over x as x approaches 0? Remember, if in doubt, you can always simply write out a little table, pick some x values, figure out what you get for the function values. In this case, I want my x values to get close to 0, and then we'll figure out what those function values are. You might need a calculator for this one. Let's start with something that's close to 0, kind of small. Put that in the calculator, see what you get. Okay, let's try another one. Again, a little bit closer. Gonna stick another 0 in there. Put that in the calculator, evaluate the cosine of 1 over this value. We end up with negative in this case. All right, so we started with a positive, now we're moving to negatives. Let's see if that pattern continues. Get something even closer. Remember, each time I'm getting a little closer to 0. This one's even smaller. Put that in the calculator, and oh, look at that, we do get another negative. I wonder, is a pattern developing here or not? Let's try another one. Get it even smaller. Oh my, now this time we get a positive. Oh wait, so our pattern, not even looking at the numbers, our pattern is positive, negative, negative, positive. This is not getting close to one single number, so it turns out that this limit also does not exist. So these limits can be a little tricky, but one-sided limits, limits of polynomial and rational functions, are actually kind of fun. Enjoy!